Hi, I'm 조혜진 from 성균관 University. Today, I'm gonna introduce about area selective atomic layer deposition. Today's contents consist of introduction, several approaches, trend and future, and summary. Although the topic has been studied by many researchers for several years, the technology is being under research. It means that the technology needs more advanced solution and it has potential to be applied to industry. So, the most of the contents of presentations are based on the paper. What is the area selective atomic layer deposition? Before explaining the area selective ALD, explanation about ALD should be done. ALD is one of the deposition method. At the surface of the substrate, by chemical adsorption of precursors and oxidant, films is deposited for atomic scale. The film deposited by ALD has excellent conformality, atomic scale thickness controllability, and low gross temperature. At traditional ALD process condition, films can be made on whole surface of the substrate. Thus, in order to make patterns, additional patterning process has been necessary. For example, photolithography and etch process are needs to make patterns, or patterned film can be formed by nano-imprinting method with solution process. However, due to very low etch rate of materials such as aluminum oxide and etch placement error and different properties between ALD films and solution processed film, demands of area selective ALD has arisen as semiconductor and display industry. For area selective deposition, many researchers has been concentrated on chemical adsorption property. ALD process is done by chemical reaction at the surface. If the surface is non-reactive functional group with reactant, the reaction cannot occur. From the idea, there has been various trials to chemical treatment. Representative trials are graphene and self-assembled monolayers. At initial study, graphene has been used for chemical treatment. Actually, the graphene method has been reported not effective. As ALD processes are proceed, chemical deposition reactions are conducted at the defect site of graphenes or the phase-swapped site. Also, synthesis of perfect graphene sheet for industry scale needs more study. Nowadays, many studies are introducing self-assembled monolayers. By using SAM with non-reactive functional tail group, reaction between precursors and surface is prevented. This paper shows the different activation energies depending on different terminated tail group. The most effective SAM material is reported as methyl-terminated SAMs. When surface is functionalized as methyl group, activation energy for deposition reaction is higher than the hydroxyl group. However, the method also has limits. SAM treatment cannot prevent deposition permanently. As ALD process is proceed, SAM chains are getting damaged. If oxidant functionalized the methyl group to hydroxyl group, deposition reaction can be conducted. It starts the deposition on damaged SAM chains as nucleation site. According to this paper, ALD can deposit aluminum oxide layers on methyl-terminated SAMs. SAMs cannot block aluminum oxide deposition when it was deposited at the thickness of greater than 6 nanometers on silicon surface. Nowadays, the researchers are using water contact angles along the process cycles in order to show the damage of SAM chains. Hydrophobicity of methyl group is shown by water contact angle. If the water contact angle is getting smaller and smaller, it means that methyl-terminated SAM chains are getting damaged. By changing the injection pressures and times of precursors, oxidant gas and purge gas, the condition without damage of SAM chain has been found. For selective deposition, low pressure and shorter injection time than traditional ALD process are needed. According to this paper, the selectivity between SAM-treated surface and not treated surface is about 6 nanometers. However, all reported papers shows good selectivity only on the metal patterned surface. For application to OLED encapsulation, good selectivity on non-metal surface is necessary. For the future technology, area selective ALD on silicon oxide surface without metal patterning is needed. Also, in order to use substrate which cannot use solution process, studies about vapor SAM treatment and patternings are also needed. The table is summary of today's presentation. Area selective ALD is necessary due to the limit of other patterning technologies, for example, photolithography and nanoimprint. At the initial period, graphene has been used for blocking materials. However, as process proceed, nucleation become formed at defect site, and synthesis of defectless graphene also has hurdle. Self-assembled monolayers has been tried to blocking method. It can formed by easy process, but as cycles are repeated, there are also nucleation of deposition reaction. For high selectivity, there are many trials to maintain SAM chains controlling injection condition. For more wide application, there are many issues. One of issue is substrate for OLED application. Another is vapor SAM patterning method. As semiconductor cell become integrated, someday small area ALD technology will be necessary. Although the technology still needs more researches, it has potential to get high selectivity and good conformality with proper properties. I hope the topic-related researches will help and lead the future technologies. These are the reference papers. Thank you for listening my presentation. If you have any interesting discussion topic, please contact me through email. Thank you.